In this lesson, we will start off by by defining some new terms. And these new terms, their purpose is to relate individual particles that make up a substance to larger quantities of that substance, so that we can relate the number of individual particles to the amount, the macroscopic amount, the mass that we have of that substance. And so this is really the first step to explaining what's going on with the molecules and atoms within a substance in terms of, to use those concepts to explain what's going on macroscopically with the substance. So the definitions that we're going to be dealing with, and I'll give the definitions clearly and briefly, and then we'll go on to make some statements that relate them to one another. A mole is an amount of a substance that contains the same number of atoms or molecules as 0.012 kilograms of carbon-12, or 12 grams of carbon-12. 12 grams is enough that you can clearly see it with the naked eye. And so what this does is it compares it kind of relates that to the number of individual atoms, which is a more abstract idea. The molar mass is the mass of 1 mole of a substance. So because we used carbon-12 to define what a mole is, carbon-12 has a mass of 12 grams. Other atoms have other molar masses. So 1 mole of, I don't know, something like uranium-235, for example, will have a very different mass to 1 mole of carbon-12 or 1 mole of hydrogen, because each of the little particles has a different mass. The Avogadro constant, which is denoted by this N subscript A, is the number of atoms in 12 grams of carbon-12. So it's basically the number of atoms in a mole. And that number is 6.022 times 10 to the 23 atoms or molecules. So we'll have a look at a couple of statements that we can make now using these concepts. We call the amount of atoms in 12 grams of carbon-12 a mole. The number of molecules or atoms in a mole, therefore, is 6.02 times 10 to the 23. A mole of hydrogen-1 has a mass of approximately 1 gram. Even though we have the same number of hydrogen atoms in a mole as we would have carbon atoms in a mole, the mass of each hydrogen atom is less than the mass of each carbon atom, because hydrogen only has 1 proton, whereas carbon has 6 protons and 6 neutrons. Carbon-12 does. 12 moles of hydrogen-1 have approximately the same mass as 1 mole of carbon-12, i.e. 12 grams. The mass number on the periodic table tells us how much a mole of that substance weighs in grams. So if you look at the periodic table, for a hydrogen, the mass number is very close to 1, which means that a mole of hydrogen has a mass of 1 gram. A mole of carbon has a mass of very close to 12 grams. The reason why it's not exactly 12 grams is because carbon-12 is not the only isotope of carbon. But we'll get to talking about isotopes later on in the course. So these terms we can use to describe relate the individual atoms or molecules making up a substance to the mass of the substance that we have. We will now have a look at a couple of worked examples, just to give us a chance to see how these quantities can be applied in practice. Alright, now to make sense of this concept of moles and molar mass, what we'll do is we'll just reason our way through a couple of multi-choice questions from the IB exams. The first one here says that carbon has a relative atomic mass of 12 and oxygen has a relative atomic mass of 16. A sample of 6 grams of carbon has twice as many atoms as, and we're given these 4 choices. Okay, well, 6 grams of carbon must be half of a mole, because 1 mole of carbon is 12 grams. So half a mole of carbon has exactly half of Avogadro's constant number of individual atoms, and so 6 grams of carbon has half a mole. So half a mole is exactly twice of a quarter of a mole. So what it's really asking us is how many grams contain a quarter of a mole of oxygen atoms, and 1 mole of oxygen has a mass of 16 grams. So a quarter mole of oxygen will have a mass of 4 grams. Okay. Example 2 asks for the definition of a mole. Again, this requires some careful reading. So the first one says that the mole is the mass of an atom of the isotope carbon-12. Well, we know that a mole is a number of atoms. It's not a mass of an atom, so we can eliminate that one straight away. It's not that one. The second one says that it's the amount of a substance that contains as many elementary entities as the number of atoms in 12 grams of the isotope carbon-12. That sounds feasible. This term elementary entities is a bit mysterious, so maybe we'll have a look at the other answers as well. C says it's the mass of 1 atom of the isotope carbon-12. That answer is exactly identical to A. It's kind of weird. So we can cross that one off too. This was taken from an exam, by the way. Then the fourth possible answer is the amount of a substance that contains as many nuclei as the number of nuclei in 12 grams of the isotope carbon-12. Okay, so it's B or D. Now, it's not D, because we can have a mole of water, and a mole of water contains 1 mole of water molecules, and each water molecule has 3 nuclei. And so it's not D either. So it must be B. And so from this we can reason that what they mean by an elementary entity is an atom or a molecule. Okay, so let's move on. What is the mass of carbon-12 that contains the same number of atoms as 14 grams of silicon-28? Okay, this is similar to the first question. So the mass of carbon-12 that contains the same number of atoms as 14 grams of silicon-28, well, 14 grams of silicon-28 must be half a mole, because the 28 there is the mass number. And so half a mole of carbon-12 has a mass of 6 grams. A container holds 20 grams of neon of mass number 20 and also 8 grams of helium of mass number 4. What is the ratio atoms of neon over atoms of helium? So if it has 20 grams of neon, it has exactly 1 mole of neon. So the number on the top is 1. It has 8 grams of helium, which has a mass number of 4, so 8 grams is 2 moles of helium. So it's 1 over 2, which is 0.5, which is B. I hope this idea of moles and molar mass is starting to become clear. We will apply them to a number of situations, which should allow us to kind of get the hang of what a mole is.